Today we're going to talk about derivatives of inverse functions. So let's first remember what an inverse is. What is an inverse? The opposite. The opposite. Okay. It's just when you switch x and y. Right, so the inverse, you just switch x and y. So if I give you just a random function right here, 1, 4, 2, 5, 3, 6, 4, 7, what's the inverse of that? 1, 4 becomes, and then you get, for those of you wishing it was going to be this easy, not even close. Alright, I'm just reminding you what an inverse is. Actually, this is just one rule, really, not that hard. Alright, so we're going to kind of do a little self-discovery of the rule here. So I'm going to give you f of x, which is x squared, and we're going to let the inverse be root x, which is actually a true statement. Find the slopes of each one at the following points, and we're going to talk about what we discover. Oh my gosh, this is so exciting. So this first one is f, because if I plug in a 2, I get a 4. So this is going to represent f, and this next one's going to represent the inverse. So let's find the derivative of f. What is f prime? Did I hear a 2x? What is f prime at x equals 2? I hear a 4? Alright. Alright, and then what's the derivative of square root of x? 1/2 x to the negative 1/2, which is the same thing as 1 over 2 root x. And I need to plug in a what this time? X equals a 4. Why are you plugging in a 4? Because it's the inverse x value. So you plug in a 4, you're going to get 1/4. Huh. What do you think the rule is? You just flip it? Let's verify that. Let's go ahead and do B. So when we go ahead and do B, why do I hear so much talking? I don't get that. I already know f prime of x equal to 2x, so when I plug in a 3, I'm going to get 6. I already know the derivative is 1 over 2 root x. When I plug in a 9, what do I get? 1/6. So the slopes of the inverses are reciprocals. I can't spell reciprocal. I need R. Spelling, you do not get taken off of spelling on the AP exam. As long as I know what you're talking about. What's that? Okay, so here's some steps with how to find the derivative. I mean, essentially, here's your formula right down here. Really what you need to find is what the f of x value is, and then take the derivative of that, and then flip it. That's all you need to do. Okay? So let's do this second problem. So we're going to have this function defined by x cubed plus 2x minus 1. Let g be the inverse. They do this a lot, by the way. They'll just let g be the inverse because it's really annoying to write this f to the negative 1 all the time. Just giving you a heads up. That's typically what ends up happening. Alright? So they're going to let g of 2 equal 1, and what's the value of g prime of 2? So to find the value of g prime of 2, I need to find the value of f prime. So if g of 2 is equal to 1, f of what equals what? 1 is equal to 2. Why is that important? Because I'm going to plug in x equals 1 into f prime. And then I'm going to flip it, and I'm going to call it a day. What is f prime? 3x squared, I hear it, plus 2. What is f prime of 1? So what's my answer going to be then? I just said it. What do you need to do once you get the f value? Just flip it and call it a day. Again, this kind of follows what we just did in our previous examples, figuring out that those derivatives are just inverses of each other. So all you need to do, because what you theoretically could do is you could find what the inverse function is, or the inverse relation is, and then do that derivative and then plug it in. You get the same answer. But yeah, it's too much work. That's going to require completing the square and stuff like that. That's too much. Don't do that. Okay, so here all you do is figure out what you're plugging into f. So this said g of 2 is 1, so I know that f of 1 is equal to 2. So that tells me I want x equals 1. Find the derivative, plug in a 1, flip it, done. That's it. Sometimes they already give us the information that we need. Sometimes they do, sometimes they don't. Let's go ahead and do 3. You want to try this one on your own? Go for it. Try it on your own, please. Some of us are just talking and doing nothing. I don't get it. I say this class is hard, but then I'm looking out at our note-taking skills and we struggle. Not all of us. What's the final answer here? 2. By the way, this is a baby chain. I just showed all the work for the baby chain. You take the derivative of the outside, and then the derivative of the inside is just a 1. Little baby chain. What's up? So you're saying that this one works because it's easy to do. I agree. This one, not easy to do. You're fine. I'm just going to let you know they'll never give you a problem where you're able to do it on an FRQ. They do for the first time in 2020. Yeah, full credit. Watch, they do. And you're going to come back. I'm going to forget about this conversation. You're going to come back to me. Guess what they did? I'm like, what? And I'm going to be like, you're crazy. I have no clue what you're talking about. All right. Typically, the AP likes to ask questions right off of a table. They like tables. They love tables. They're a big fan of tables. Okay, so the table above gives the selected values for a differentiable and decreasing function f and its derivative. So we need to find the value of inverse prime 2. Okay. So this one's kind of a little bit weirder. We need to find the original f function. F of what equals 2? What x value is going to have an output of 2? X equals 1. So I have f of 1 equals 2. I need f prime of 1. That's negative 8. So what's my answer going to be? The answer's not negative 8. Negative 1/8. All you really need to do is just to find one part of the table. Typical mistake. People try to use this one. They're like, oh, it's negative 1 over 80. You always have to find out through this middle column right here. Okay, because they're going to give you this information. Look at the middle column. Oh, it's at x equals 1. Derivative is negative 8. Flip it, negative 1 over 8. So let's go ahead and do B. It should take you about 10 seconds to do B. I'm going to call a random person. Neelish, you're safe. I'm not going to call on you. That's a trick, Neelish. No, it's not a trick. Or is it? Zoom in. Do you not have your sheet? Too bad I don't have any seats towards the front. Conch, what'd you get? Yes! Negative 1 over 80! Because you're looking at this column. That's a derivative in this column. It's negative 80. You have to do the reciprocal. You're going to get negative 1 over 80. Woo! Not the hardest lesson in the world. Yes. That's as much work as I would show. Yep. Alright, with that becomes the inverse trig stuff, just more stuff for you to memorize. Okay, so how this is going to work is we have u as a function, so it's a derivative of arc sine of u. I just have to tell you, it's going to be u prime, so whatever the derivative, I'm already telling you what the chain rule is of this. Kind of annoying, but the definition I like the best is on that sheet of paper I gave you. Remember that little packet that had everything you need to know? Yeah, this is in there. And then just use u as a function. That's a u. So it's u prime over square root of 1 minus u squared. For arc cosine, because it starts with a c, it's going to be negative. It's going to be negative u prime over square root of 1 minus u squared. Arc tangent. This is just all definitions. U prime over 1 plus u squared. Like I said, on that little packet thing, I like those definitions better because they don't tell you the chain rule definition. But anyway, let's just go through two more problems, and that's all I got for you today. Nice short little video, hopefully under 20 minutes. So for number 4, what's my u value? In other words, what's my inside value of my chain, really? 2x. What's the derivative of 2x? So y prime, you're going to get 2 over square root of 1 minus 2x all squared, which is equal to alright, and then is that hard? If you know the formula, it's not that hard. And then for number 5, what's the derivative of the inside? 6x over 1 plus 3x squared minus 1 all squared. I'm not going to simplify that any further. Inverse stuff, like in BC calculus, you had to be like experts on this stuff. Not in AB, unfortunately. This is as much as you really need to know. Alright. Questions, comments, concerns? If you have any questions, I don't care. Hit the dislike button, unsubscribe, whatever. That's the inverse of what I would usually say. I hate my teacher.